Hello everyone, and welcome to the continuation of our unit on systems and particularly their applications. We're going to be talking today about digit problems, as they're often referred. So in these problems, we have to remember that a number in the tens place is worth 10 times as much as a number in the units or ones place. Sometimes students are thrown off by the words unit digit. That's also like the ones digit. Those can be used interchangeably. So let's look at this example and get started. The units digit of a two-digit number is 1 less than 3 times the tens digit. If the digits are reversed, the new number is 45 more than the original number. Find the original number. So for these problems, we need to consider the digits of the number we're looking for independently. So I'm going to say that x is equal to the units digit, and y is equal to the tens digit. Great, those are our variables. Let's look at what information they've told us. They've told us that it's a two-digit number and the units digit is 1 less than 3 times the tens digit. So that basically leads us to an equation. The units digit, x, is 1 less than 3 times the tens digit. So 3 times the tens digit and 1 less than that. So that's our first equation right from that first sentence. The second equation gets a little bit more interesting. It says if the digits are reversed, the new number is 45 more than the original number. So this is where we really want to say the old number, which looked like y then an x, is 45, is less than the other number, but the other number is kind of xy in order, but it's 45 more. But this equation is not what we're looking for, because mathematically, when we write y next to x, we don't mean put the number for y and then put the number for x. This would mean multiply. So this is not the equation we're looking for. Students may be interested in, or trapped into writing yx, xy as the digits reversed, but that's not mathematically equivalent to the digits reversed. We need to remember that y and x are in different place value. So if we want to represent the original number with y and x, the tens digit has to be multiplied by 10. So 10y would kind of take that y value and bump it into the tens place, and we can add the units digit, x. That is our original number, 10 times the tens digit and 1 times the units digit. So that's the original number. And then it says the new number is 45 more than the original number when the digits are reversed. So I know that the old number was smaller, so I'm going to actually add 45 to the original number, and that is going to be the new number. So the new number now has x in the tens place. So that's why in the new number, 10 gets multiplied by x, and y just gets multiplied by 1. So this is reversed which digit has a value of 10, or is in the tens place. So here's our second equation. So recapping that one more time, because that was a lot to digest. We multiplied the tens digit by 10. That kind of moves it into the tens place. If we think about like the number 27, if x is 2 and x is 7 and y is 2, I can't just simply put 7 next to 2. That would look like 14. But if I wanted to take 7 and 2 and create the number 27, what I have to do is take the y value, 2, multiply it by 10, and then add 7. Then that would give me 27. So the tens place digit has to get multiplied by 10. So that helps us create the original number, 45 more, and that's going to equal the new number with the digits reversed. Okay, so because of the way this system was written, I already have one variable solved for in our first equation. So this is going to let us to system by substitution. So I'm going to rewrite the second equation, 10y, but I'm going to replace x with 3y minus 1, add 45. And on the other side, I'm going to do the same thing. So 10 here, and then we'll replace x with 3y minus 1 plus y. Great, so I've got a lot of simplifying to do. I've got 10y and 3y is 13y, and I've got 44 on this side. On the other side, I can distribute that 10, and I get 30y minus 10 plus y. So I'll clean up the right-hand side, copy the left-hand side. So I have 31y minus 10. Great, I'm getting closer now. I can subtract 13y from both sides. 44 is equal to 18y minus 10. Let's just drag that up here. So 44 equals 18y minus 10. I can add 10 to both sides. 54 equals 18y, and I can divide both sides by 18, and we get 3 is equal to y. So what does that mean? That means the tens digit is 3. So we can go back to either of our equations to find the x value. So we've got one that's already solved for x, so that's probably our best place. So x is equal to 3 times 3 minus 1. So x is equal to 9 minus 1, or x is equal to 8. So it wanted us to find the original number. So from our definition of our variables, x is the unit digit, y is the tens digit. So we have those numbers. So the original number is 38. Terrific. Let's look at a second example of this. Okay, so in this instance, it says the sum of the digits of a certain two-digit number is 7. Reversing the digits increases the number by 9. What is the number? Very similar to the last one. Let's let x equal the units digit, and y equal the tens digit. So the sum of the digits of the number is 7. So that's a nice equation. X plus y equals 7. And the second part is, again, reversing the digits. So reversing the digits increases the number by 9. So let's recreate the original number. The original number is 10y plus x. 10 because that's in the tens place, plus x because it's in the units place. And if we reverse that number, it says the new number will be 9 bigger. So I'm going to add 9 to this number to make it equal to the new number. So again, the new number now has the x in the tens place, so we need to multiply that by 10 and then add y, and that's our second equation. So we have our system of equations written. We have a number of choices for how we might choose to solve for that. So I'm going to go ahead and choose to solve for this by taking the first equation and solving for x. So I'm going to subtract y on both sides and get x is equal to 7 minus y. And I'm going to go ahead and plug that into our second equation. So I have 10y plus 7 minus y plus 9 equals 10, and then in parentheses 7 minus y plus y. Okay, we have an equation with just one variable, so we can go ahead and solve. Let's combine some like terms over here. So we've got 10y and negative y, so that's 9y, and 7 and 9 is 16. On the other side, we've got 70 minus 10y plus y. So I'll copy the left side down. 9y plus 16 equals 70 minus 9y. Okay, we're almost there. I'm going to add 9y to both sides, and we get 18y plus 16 equals 70, and we can subtract 16 from both sides, and we get 18y equals 54. Divide both sides by 18, and running out of room down here, y is equal to 3, of course. So we'll go back and find x. We know that x plus y is equal to 7, so x plus 3 equals 7, so of course x is 4. So they say, what is the number? They're referring to the original number, so x is the units digit, y is the tens digit, so the, maybe we should even add clarification, the original number is 34. So these are digits problems. You really have to take into account the fact that the digit in the tens place is worth 10 times as much as its digit. So you can multiply it by 10 and then add the units digit to create that number mathematically in an expression. Thanks again, and join us for other systems of equations application problems.